Hello explorers! Today we're going to do some science sketchnoting on energy with a focus on energy transformations and conservation. So grab your favorite shade of chartreuse, aquamarine, or razzmatazz, and let's get sketching. The title for today's sketchnote is Energy Transformations and Conservation. Go ahead and put a little box around your title. Now I want you to think to yourself, how are different forms of energy related? How are they related to one another? Well, in this unit, remember we learned that most forms of energy can be transformed into other forms of energy. So let's talk a little bit, what do we mean by an energy transformation? And an energy transformation is what happens when we have a change from one form of energy into another. Okay? And we have a couple different kinds of changes. We have our, oops, it's too long. We have single transformations. Right? A single transformation. I'm going to put an S before the F there. And I want you to imagine that you and I were hanging out for breakfast this morning. And we decided, oh, it is a great day for toast. And of course, my toaster is a lovely shade of red. We sit down, we put our gluten-free, of course, for me, toast inside. And it gets all nice and toasty. What's happening inside the toaster? Well, my toaster takes electrical energy and it transforms it into thermal energy. And it's the thermal elements inside the toaster that are doing the toasting. Right? That's my single transformation from electrical to thermal in my toaster. We also have multiple transformations. Right? Single transformation in our toaster. And we're going to talk about multiple transformations next. So let's imagine we're camping together. And it's dark out. We need to go find where our tents are, right? So we turn on our flashlights. There's our lovely light from our flashlight. Let's go ahead and make our flashlight a nice shade of seafoam green, because why not? And what's happening inside my flashlight is that we have the chemical energy that is stored in the batteries, right? It's electrical energy that's stored in chemical, which turns into electrical energy, and I turn it on, which then goes to thermal energy in the bulb, so I can feel it heating up and being warm. So let's imagine for a second that I had this lovely apple for lunch. And we're going to use chartreuse. Oh, yay. Look at that lovely shade of chartreuse. I had an apple for lunch, right? And I know that my apple contains chemical energy. I'm going to use that chemical energy to go for a bike ride. Okay? And my body now, oh geez, there we go. I'm on a bike ride. I'm changing the chemical energy found in the apple to mechanical energy, and that's what makes my bike move. Right? Because my legs are pumping. I have the mechanical energy from the stored energy, the chemical energy in the apple. Now, and that'd be is that a single transformation or a multiple transformation? Single transformation, right. Now let's imagine that I'm sitting at my dining room table and I'm really warm as I'm working on all my homework, right? So I go ahead and I decide I'm going to turn on my ceiling fan. I actually don't have a ceiling fan. We're pretending I do for the sake of this example here. I turn on my ceiling fan. Oh, and it starts blowing lovely air at me. Now here I've got electrical energy, right, that my fan is taking in, and it's changing it into kinetic energy because the fan blades are moving. But some of that energy is also, some of the electrical energy kind of gets lost. It doesn't all get transformed to kinetic because some of it goes to the thermal energy of heating up the motor. And if I were to, so the thermal energy in the fan's motor, if I were to touch the fan's motor, it'd probably be pretty warm after it's been going for a while. So that's my fan. Now, the most common energy transformation, I think the most common energy transformation is. The most common transformation is between potential and kinetic. Potential and kinetic. Potential, kinetic. Remember, potential energy is due to an object's position or shape. And what's kinetic again? Kinetic energy is the energy an object has due to its motion. Now, we are on our way to Walt Disney World, everyone. And we are going on a roller coaster because I love roller coasters. There's a little track. Okay. And here we are as a whole class. We are in. Here we're going, oh my gosh, we're going up. And we're up here at the very top. At the very top of this roller coaster hill, right, we have our greatest potential energy in the form of gravitational, right? It's our greatest potential energy. Now, we are going to speed up as we're going on this hill. We're speeding up, right? And if you were in a car with me, on a roller coaster car, you would, at this point, hear me scream, because I would scream a lot. So I love roller coasters, even though they kind of scare me a little. But that's the whole point, right? And now we're down here. At this point, the lower point of the roller coaster track, we're at our greatest kinetic potential. And then we go back up, and so on and so forth, as the ride goes through, right? And that's a transformation between our potential energy and our kinetic energy. And that's one of the most common forms of energy transformations. Now, we'd be remiss in talking about all of this without talking about the law of conservation of energy. And can any of you remember what that law means? Right, it is that energy cannot be created or destroyed. Right? And that means that we have the total energy is going to be the same before and after any transformation. Okay, any transformation. We're going to do a couple examples here. Before and after. So, you and I and the whole class, we are, my person's head's too big. We're going bowling, right? We are bowling. We're at the bowling lanes, we're going, and there we are, right? My bowling ball, which I've just launched at all of the pins that are here. Which surprisingly, I feel like are more challenging to draw than when I initially see that. Oh well, it'll work. You get the idea. You know what I'm going to do? I'm going to add red stripes to them, and then you'll for sure know I'm talking about bowling pins. Oh, look at that. They're amazing. All right, so I have my bowling ball, and it is rolling down. Now, some of my bowling ball's energy is lost. Where is it lost to? It's lost to friction, right? Friction. So, the rest of the kinetic energy gets transformed to the bowling pins where they crack, right? So my energy is transferred from the ball, the ball to the pins. All right, transferred right there. Okay. Now, let's have our big idea here that energy can change from one type to another, right? Remember that energy can change one type to another. Come on, straight line. But the total amount of energy is always conserved, right? We talked about that. Right? The total amount of energy is always conserved. So when I am in my kitchen and I'm making delicious popcorn, right? Popcorn in my microwave. So that's popcorn. We'll label it as such so you understand what I'm talking about. That's my microwave, right? We have the form of energy of the electromagnetic, right? Which gets transformed to thermal energy, which heats up my popcorn, right? But the amount of energy that went in is the same that comes out. Now, your next thing is to imagine that This is big stair. Because right now we're going to the circus. And Miss Little right now is on a trapeze. Fun fact, I've actually been on a trapeze, and I've even done this. So here I am. I'm standing right here on the trapeze. And then I go, right? And I am now hanging from the trapeze. Ah. Here's all down below, right? And I'm here. Okay. Hair is down below like this. And then I'm back over to this part of the swing. Okay. Right before I get caught. Now, your job to fill in is number 1 and number 2. And number 1, I want you to think in both these numbers, tell me where the greatest potential energy I have and where the greatest kinetic energy is that I have. And there you go. That is our energy transformation and conservation sketch note. Thanks for sketching with me, explorers. I'm looking forward to seeing your work. And remember, keep exploring. Bye!